Okay, we're going to be looking at the special right triangles. You guys saw this in geometry. Remember the 45, 45, 90 and the 30, 60, 90. You remember those. So we're going to be dealing with those again. We need to know those. It helps a lot for next year as well. So let me come over here in space number 1. I'm going to come up with the formulas. Remember, there were some formulas. So let me just draw to begin with. Let me just draw a triangle. I'm going to say there's a 90 degrees, 45, and 45. So we call this the 45, 45, 90 triangle. It's in reference of our angles. And let's say I gave you one side. Let's say I gave you one side, and then I said this side right here is 5, and you had to figure the other two sides. Well, interesting part is because two angles are equal, two sides are equal. And the two sides that are equal are the two sides that meet at the 90-degree corner. So one side is 5, well, the other one side is 5 as well. The third side, the hypotenuse for right now, let me call it x, because I don't know how big that is. Now, I remember Pythagorean theorem. Remember a squared plus b squared equals c squared. So I'm just going to write 5 squared plus 5 squared, it's equal to x squared. I'm going to use Pythagorean theorem to solve for x. Now, I know 5 squared is 25, so I have 25 plus 25 is x squared. I know 25 plus 25 is 50, so let me write this as 50, it's equal to x squared. So I'm going to say the square root of 50 is going to be equal to x. Remember, exponents and roots, in this case a square exponent, so a square root, undo each other. Now you guys learn how to simplify radicals. Now this one, I'm going to split it as to two radicals, right? Square root of 50, I'm going to split it as to two radicals, but one of them has to be a perfect square. You guys remember like 1 times 1, 2 times 2, 3 times 3, or 4 times 4, on and on. That's what gives me perfect square. So I'm thinking of two numbers that multiplied equals 50, but one of them has to be a perfect square. In my case, I'm going to think 25 times 2, right? 25 times 2 is 50. 25 is a perfect square. I know the square root of 25 is 5. So I'm going to say this thing simplifies. So x is going to be 5 radical 2. Now this is doing it the long way. This is a long way. Let me go over it to a short way. Now the long way we're going to use, in case you guys ever forget the formula, or you guys think the formula is it's too hard, then you're going to use Pythagorean theorem. If I started at one side and I want to get to the hypotenuse, I multiplied by radical 2. And look, if I would have gone 5 times radical 2, it's 5 square root of 2. That's it. 5 square root of 2. Now, if you're going backwards, because sometimes we might have it, if you're going backwards, you're going to divide by the square root of 2. Okay. Let me show you an example. Let me show you an example here for number 2. Find the missing side lengths. Do not convert your answer to decimal form, and rationalize the denominator if necessary. Okay, so my answer is not going to be in decimals. Now, rationalize means obviously simplify everything, but you cannot have radicals at the bottom. You cannot have square roots at the bottom. So let's see. Here I'm finding both sides, right? In your homework, I'm going to ask for a specific side, but here I'm going to solve for both of them. So here I'm starting from the hypotenuse. So to get to y, I have to divide by radical 2. So I'm going to say y is equal to 8 divided by the square root of 2. Now remember, I cannot have decimals. I'm not going to move this to decimals. Another thing that I was told is rationalize. So no radicals at the bottom. Now what I'm going to do, let me multiply top and bottom by the square root of 2. So on the top, I have 8 square root of 2. At the bottom, I just have 2. When you multiply the radical by itself, basically it's going to be radical 2 squared. I'm just going to get the number in the inside. Square root of 2 times square root of 2 is just 2. So if I had square root of 3 times square root of 3, my answer would just be 3. When you multiply a radical by itself, you just get the number in the inside. Now, I want us to focus here on my fraction. 8 over 2, those are whole numbers. Let me divide each by 2. So let's see, I'm going to have 4 radical 2 over 1. Because notice how each of my whole numbers, I divided by 2. Now, when there's a fraction and there's a 1 at the bottom, it's not a fraction anymore, right? So my y is going to be 4 radical 2. Now, if I wanted to solve for x, same thing, 4 radical 2. Because remember, I said the two sides that meet at the 90-degree corner are equal. Okay, now let's take a look at another formula. Now this one, we're going to start from a 60, 60, 60 triangle. So 60, 60, 60. So that means all the angles are equal. Because all the angles are equal, let me start saying that all the sides are equal. Let's say the side was 8. Just to give you a value here, let's say each side was 8. Now that would be too boring. So what I'm going to do instead, I'm going to cut one angle in half to make a 90-degree angle here. So instead of 60, I have 30, 60, and 90. Now the interesting part is the 8 at the bottom, I'm also going to cut it in half, right? So 4 and 4. Now I want us to focus on this triangle. I have a 30, 60, 90 triangle. So I'm going to erase this. I don't need this anymore. Interesting part of the 30, 60, 90 triangle, the smallest side is the one away from the 30 degrees. And the hypotenuse is the one angle away from the biggest side. Interesting part is the small side is always half of the big side, right? 4 is half of 8. Now, if I give you the small side, obviously multiply by 2. The relationship between those two is the small side is half of the big side, or the big side is the small side times 2, right? 4 times 2 gives me 8, or the half of 8 gives me 4. So that's that. Now, let me come up with a formula to solve for the third side. I'm going to use Pythagorean theorem again. I'm going to use Pythagorean theorem here. So I'm going to go 4 squared, or x squared, plus 4 squared, it's equal to 8 squared. So I have that x squared plus 16, it's equal to 64. Now this plus 16, let me move it over as a minus 16. So I get that x squared is equal to, now 64 minus 16, I get 48. So that means that x is the square root of 48. Okay, now 48, I'm going to break that as 16 times 3. 16 is a perfect square, so that means that my x in this case is 4 radical 3, right? The square root of 16 is 4, so it becomes a whole number. I just simplify that. So I guess let me erase this right here, this x right here, let me erase that, and let me write this as a 4 radical 3. The key number here is going to be our small side. Let me go over our formulas. Easy way to do this. I mentioned earlier, if you're going to the hypotenuse, you multiply by 2, right? 4 times 2. If you're going to this other side, you multiplied by the square root of 3. See, that's what I did, 4 times square root of 3. Obviously, you're going backwards. If I'm going here, I will divide, or if I'm going from the hypotenuse, I will divide. Let's take a look at an example. I'm given the hypotenuse. I want to get to the small side. I know I have to divide. Remember we said from the hypotenuse to the small side we divide. So let me write this as 5 divided by 2. I'm going to write it as a fraction. My instruction said don't make it into a decimal, so that's it. Just leave it as a fraction, 5 over 2. Now that I have the small side, I can get to this side because I have to multiply this by radical 3. So it's basically 5 over 2 times radical 3. I'm only going to multiply the radical with the top. So it's going to be 5 square root of 3 over 2. My square root is simple 5. My fraction is simple 5. I don't have square roots at the bottom, so I'm good. Want you guys to practice these. So question number one, space number one, I showed you guys using Pythagorean theorem. How do we come up with the formulas? If you guys don't know how to use the formulas, you can always use Pythagorean theorem.